Class, turn to page 53. We're going to draw the orbital overlap of BCl3, and it is a past year question which worth 7 marks. So first of all, you have to determine the molecular geometry. So first thing first, you have to draw your Lewis structure first. So B has 3 valence, so 3Cl would be 21 electrons, so the total would be 24. So BCl3 minus 6, 24 minus 6 would be 18. 1, 2, 3, 4, 6, 8, 9, 10. So minus 18. So there's no lone pairs in your central atom or boron. So this is your Lewis structure. Okay, so you're going to determine the molecular geometry. Okay, so this consists of 3 body pairs plus 0 lone pairs. So 3 terminal atoms would has a molecular geometry of trigonal planar. So trigonal planar, you draw it like this. So first off, after you have drew your molecular geometry, you have to determine the type of hybridization for central and terminal atom is necessary. Okay, so for boron, we've got 3 single bonds, so 1, 2, 3 sigma. So 3 sigma plus 0 lone pairs, there would be 3 electron. Okay, so it would has a type of hybrid of sp2. So sp2 would has a shape of trigonal planar. So now we're going to draw the ground excited and hybrid state for central atom only, because your terminal bonded via single bond, so you don't have to determine the type of hybridization and the ground excited and hybrid state. Okay, so let's start. Okay, so first thing, you have to know the proton number for boron. So boron has 5 proton numbers, so write the electronic configuration: 1s2, 2s2, 2p1. So for the ground state, this is my short form. So in exam, you have to write it in full words. So the ground state, it is you just have to draw the orbital with highest n. Okay, so for this boron, the highest n would be 2. So you've got 2s2, 2p1, 2s2, 2p1. Okay. So for excited state, you have to make the electron become unpaired. Okay, if there is empty orbital. So check your ground state. So this electron into S is paired. Okay, so for excited state, I don't want it to pair, and you must check that the last orbital has empty orbital. So yes, you can jump this electron or excite this electron to this empty orbital of 2p. So your orbital of for excited state would be, so 2s now only has 1 electron and 2p now has 2 electron. Okay, remember that yes, you can change the spin of this electron from negative to positive half. So for hybrid state, you have to refer to your structure. Refer to your molecular geometry again. Then you have drew earlier. So this is boron. So boron, we've already determined that it has a type of hybrid of sp2. So now at the excited state, you have to combining 1s and 2p orbitals to become sp2 hybrid orbital. So we are combining 1s and 2p orbital. So we call this sp2 hybrid orbital. And this the last orbital in here. So it is empty, so still you have to draw it, but just write it as empty 2p orbital. Okay, so for terminal atom, check. So it is bonded via single bond, right? So look back at the explanation. Okay, So it is bonded via single bond. Then we just need to know the shape of the last orbital from electronic configuration. So Cl has a proton number of 17, so that would be 1s2, 2s2, 2p6, 3s2, 3p5. So the last orbital is p orbital. So p orbital has a dumbbell shape like this. Okay, so check. Okay, my lobes is in equal size, so I don't want you to draw it like this. Okay, make sure that all your lobes is of same size. Now we're going to draw your orbital overlap. So check again your molecular geometry. So sp2 has the shape of trigonal planar. So trigonal planar must be drawn like this. Where is it? Is trigonal planar. Yes, so your boron wood has this structure 1, 2, 3. It is difficult for me to draw it using my pen. Okay, but I'll try my best. So 1, 2, nope. Okay, this is the best that I can draw. So this is your boron. So write B at the center, and the hybrid orbital is sp2. So write it off, sp2, sp2, sp2. So now overlap it with your terminal atom, which has a shape of p orbitals. So p orbitals overlap it. So 1 Cl, 2 Cl, and 3 Cl. Draw your p shape. Draw your dumbbell correctly, okay? It is very hard for me to draw it, so let's write Cl at the center of your p orbital, and this would be 3p, 3p, and 3p orbitals. Now label the orbital overlap with sigma and check it with your molecular geometry. So for BCl3, yes, B is bonded to 3Cl in a shape of trigonal planar, and we have 3 sigma bonds. So for explanation, you just have to explain how sigma or pi bonds, if exist, form, and determine the molecular geometry and bond angle at last. So for BCl3, so look back at your orbital overlap. So 3 sp2 hybrid orbitals of boron overlap with 3 3p orbitals of Cl to form 3 sigma bonds, right? So the molecular geometry is trigonal planar and the bond angle is 120 degree. So the 7 marks, you can see it at the notes in the TC. So remember class, this is just the basic structure. So I want you to understand this first, and then we carry on with the later structure, which is much more difficult and more complex. Okay, so that's all for me. Thank you. Sorry class, one thing I forgot. I want you to write down these notes in anywhere in your tutorial. So check for hybrid orbital, it is only reserved for lone pairs and sigma bonds electron. But for unhybridized orbital, we're going to do it for CO2, which has a pi bond. It is reserved only for pi bond. Okay, so check with your hybrid state. So sp2 hybrid orbital. So this is hybrid orbital. Okay, so hybrid orbital is only for lone pair and sigma bond. So boron got no lone pairs, but we've got 3 sigma. So this 3 electron in hybrid orbital is reserved for 1, 2, 3 sigma bonds. And yes, the drawing of orbital overlap has 1, 2, and 3 sigma bonds. Okay, so that's all. Thank you, everyone.